Hello, Topaz students and parents. This is Mrs. Visconti coming to you from Unit 3, which is division, and we are working using our two-column note system to help us divide and then check our work with multiplication. Let's go ahead and work on some expanded notation method for division. Over here, I'm going to write my division problem, and then any of my work with multiplication will be done on this side to check that my work is being done correctly. So I'm going to start with the dividend 740, which is on the inside, and my 4 as my divisor, which is on the outside. So the way that the students have been learning to do this is that they cover up the problem and they reveal one number at a time. So the first number is a 7. I ask, can 7 be divided by 4? The answer is yes, it is large enough. And I'm going to go ahead and over here, we're going to do 4 times something. So 4 times 1 is going to give me a 4, which is less than 7. So I am multiplying by 1. Now I slowly reveal the other digits behind it, and that is a 4 and a 0, which is 2 place values, which equals 2 zeros. So I am, in essence, actually multiplying 4 times 100, which is 400. The way the students and I work this out is that any number below the line goes below the line here. So I have 740 minus 400. And any number above the line goes up at the top here in our quotient. Now I subtract. So I'm going to go ahead and subtract 740, take away 400, which ends up being 340. All right, I'm ready to do my next problem again, doing my division on this side and my multiplication on this side. I start by covering up the digits, and I notice that 4 is too large to be divided into 3, so I uncover the next digit. So now I'm working with 34. 4 can be divided into 34, and I'm going to go over here now. I know that 4 times 8 is going to give us 32. But I do notice that there is another place value, so I am working in the tens. So there's 32 with a 0 on the end. That is 320. So again, I know that anything below the line here goes below the line on this side, where I will subtract. And anything above this line here, this is the line I'm speaking of, this 80 will go up here above the 100. Again, this is expanded notation. It's very much like our older algorithm math that we were taught when we were younger, except that we break it into place values and then add them all together at the end. So now I'm ready to subtract here. 340 minus 320, it gives me 20. Now, the students will know this because I say this in class a lot. My brain is happy because I automatically know that something times 4 is going to give me 20 exactly. So I'm going back over here, again, only multiplying by 4. And I know that 4 times 5 gives me exactly 20. There are no other place values after, so I do not need to add any zeros. Oop. So I have 20 minus 20. And then my 5 here goes up at the top. Let's go ahead and finish our division problem down here. 20 minus 20 gives me a 0. No remainders for this problem. So now I can work back up at the top here. I'm going to take these 3 numbers and I'm going to have 185 as my answer to this division problem by adding all of these quotients back together. So this is our two-column note system used to do long division with multiplication on one side to check our work and division on the other side. The purpose is to get down to the bottom and either end up with a 0 or with a remainder. So let's go ahead and do one problem with a remainder. All right, I have my two-column notes all set up and I am ready to go ahead and start dividing. We are going to be dividing 851 divided by 7. So if you notice, I draw my problem a little bit further down below my line because I want room to go ahead and add up my quotients together. And again, I will be doing multiplication on this side to check my work. So we start off by covering the digits and revealing just the 1, and I have 8. And 8 can be divided by 7, not evenly, but it can. And I go ahead and on this side then mark that 7 times 1 is going to give me a number less than 8. Once I reveal that there are two other place values after the digit we're dividing, I can go ahead and add 2 zeros to my problem, which gives me 7 times 100. And we know that 7 times 100 is 7. 700 is below the line, so I'm going to go over here and I'm going to write 700 below the line, which will give me a subtraction problem. And then my 100 goes above the line because that is going to be a part of my quotient. So let's go ahead and move on up here, and I'm going to subtract. I have 151. All right, so starting the same process over again, but now with this new number, I cover up all the digits except for the first one. 7 cannot be divided into 1. 1 is too small. There's nothing times 7 that will make it less than 1 other than 0. So we're going to move on to the next number and reveal the next number. Hey, I know that my 7 multiplication tables, there is a number that will be less than 15. So I'm going to go on to this side over here. I know that 7 times 2 is going to give me 14, which is less than 15. There is a single digit in this place value after the number we're working with, so I'm going to apply 1 0 in this place value on this side. So I know that I'm actually multiplying by 20, not by 2. If I were to multiply just by 2, then I would have 151 minus 14, and we're not doing that. We're actually working with some tens. So 7 times 2 is 14, and we have a 0 in the ones place. So once again, this number is below this line, so I'm going to move it over here so that it can be involved in this subtraction problem. And then this number up at the top goes right back up at the top over the 100 because that will be added into our quotient. So let's go ahead now and do some subtraction. That is 0. This is 1 and 1. I am left with 11. I do not need to cover anything up because I know that 7 times 1 is going to get me something lower than 11. So I'm going to go back over here to my multiplication side. 7 times 1 is 7. Once again, because it is below the line, the 7 is going to go here into my subtraction problem. And my 1, got to slide up here, goes up here into my quotient. So now let's go back down and do some subtraction. 11 minus 7 is 4. 7 is greater than 4. So I know that I cannot do any subtraction. 4 is now too small, so I do have a remainder in this number. So let's go back up to the top. Let's add our quotients together. I have 121, remainder 4. This is the answer to my division problem with a remainder. I hope this has helped and that when you continue to do your division problems at home, you create your 2-column notes with your division on one side and your multiplication on the other side. See you later.